Alrighty, number 26. Are the two triangles similar? How do you know? So if we're looking at this, we notice that we only have information about angles. We don't have anything about sides. So our only option for congruence or similarity is by the angle-angle postulate. So I do notice that I have 60 degrees and 60 degrees congruent, but I'm missing an angle in each triangle. So I just have to find the missing angle first by the sum of 180. So 60 and 53, and subtract that from 180 gives me 67 degrees for this measurement. And if I went over and did the smaller triangle instead first, if I subtracted 127 from 180, I would get 53. So don't just assume they're going to match, do the math. And so we do have at least two sets of angles congruent. So this means, yes, they are. By the angle-angle postulate. Alrighty. Number 27, state whether the triangles are similar. If so, write a similarity statement and the postulator theorem you used. So let's notice that here we have an isosceles triangle. Two sides are congruent. If I look over here, I also have two sides congruent. So I know my 5s compare to 7.5, and then 8 compares to 12. I have all three sets of sides, but I need to make sure that the proportions are congruent, or equal. So 5 is to 7.5 as 8 is to 12. So we're going to check this if you want on your calculator. 5 divided by 7.5, and we'll reduce the fraction. That reduces to 2/3, and then we have 8/12, and that also reduces to 2/3. So we are certain that their scale factors match up. So we can say triangle, so A, B, C, is similar to triangle. So A corresponds to, and in this case, since it's isosceles, we could really say O or M, but I'll do M and O. So M and O, A, B, C, and by the side postulate. All right. 28. Michelle wanted to measure the height of her school's flagpole. She placed a mirror on the ground 48 feet from the ground, or from the flagpole, then walked backwards until she was able to see the top of the pole in the mirror. Her eyes were 5 feet above the ground, and she was 12 feet from the mirror. Using similar triangles, find the height of the flagpole to the nearest tenth of a foot. So we know what to compare to what. Okay, so the height here, 5 compares to x, 48 compares to 12. So pick a pattern. So I'm going to go large triangle to small. X is to 5 as 48 is to 12. I also notice here I can reduce this fraction right away so that it makes life a little bit easier. So 1 times x is x. 5 times 4 is 20. So we know this is 20 feet. Alrighty, number 29. What is the value of x given that PQ is parallel to BC? So if we know these are parallel, that means these are broken into proportional pieces. So 8 is to x as 12 is to 18, and I get to cross multiply. 12 times, I could have reduced that, but I wrote it, so I'm going to leave it. 8 times 18 is 144, divide by 12, and I got x is equal to 12. Some more proportional pieces with parallel lines. So if you see those little arrows in there, I can fill those in to make it a little more clear. But we have parallel lines. So again, breaking into proportional pieces. 24 is to x as 36 is to 12. Now I won't be speeding through, and I will reduce that. So 3 times x is 3x. 24 times 1, divide by 3. X is equal to 8. Number 31, what is the value of x to the nearest tenth? Okay, so we have an angle bisector. Again, cut into proportional pieces. X is to 8.2, as 14.8 is to 5.5. So I'm going to cross multiply 5.5x. 8.2 times 14.8 is 121.36. Alrighty, now we will divide 121.36 by 5.5, and we get to the nearest tenth, so x is equal to 22.1. Alright. Number 32. So we are down to right triangles, and we are going to use Pythagorean theorem. Since we have the hypotenuse, we know that the hypotenuse squared minus the leg squared gives me our other leg squared. So 25 squared, subtract 24 squared, gives me 49. Take the square root, and my missing value is 7. Again, always remember, does this make sense in the problem? We know our hypotenuse has to be the longest side, so this answer is less than 25. If you accidentally did 24 squared plus 25 squared, you're going to get a number larger than 25. And hopefully you say to yourself, that doesn't make sense. I might have made a mistake. So again, we were given the hypotenuse, so our legs have to be smaller. Number 33. In triangle ABC, angle A is a right angle. Angle B is 45 degrees. Find BC. If your answer is not an integer, leave it in simplest radical form. So we talked about our special right triangles where we had the model, when we had 45, 45, 90s, that our legs were the same value, and our hypotenuse was that value times the square root of 2. So if I know this is 13, I know this is 13, and the hypotenuse will be 13 square root 2. I said square root 2, but I wrote 3. But again, you could use trig if you did not want to memorize your right triangle. So I'm going to go back and do this the same way. So if I'm looking at this in the trig method, I have opposite and I have hypotenuse. So sine is a trig function that uses O and H. So the sine of 45 is equal to 13 over x. And then I cross multiply. So I have x times the sine of 45 is equal to 13. I divide by the sine of 45. X is equal to 13 divided by the sine of 45. Make sure you're in degree mode. And we get 18.4. So if we went back and typed in our calculator 13 square root 2, it is equivalent to 18.4. So those are equivalent answers. Alright, number 34. Find the length of the leg. If your answer is not an integer, leave it in simplest radical form. Okay, so again, I'm going to solve this with trig. The shortcut was divide by 2 and taking the square root 2. So 9 square root 2 would be the legs for both of these if we used our pattern finding. However, again, I'm going to solve it using trig.